Welcome to the Lipid Maps Podcast. Today we're joined by Rosário Domingues from the University of Aveiro in Portugal. Welcome, Rosário, to the podcast.
Thank you, Matthew. Thank you for the opportunity and for the invitation. And so to be here to share with the Lipid Maps Consortium what we are doing in our university.
So you're the leader of the lipidomic lab and the marine lipidomic lab as well. And looking at your recent publication record, there's a huge range of work that you do. So can you give us an overview of what the lab does?
Thank you so much. So in fact, we are a lipidomic lab from the Mass Spectrometry Center of the University of Aveiro. So our main skills is based on mass spectrometry. But so with the starting of lipidomics, we just started working also on the LCML's analysis of lipids. Now, in lipidomic lab, we aim to unravel the complexity and diversity of the lipidome of different organisms, as well as to develop analytical solutions for identification and quantification of modified lipids, also called EpiLipidNET, and for sure all of you already heard about it.
Yes, if people would like to know more about EpiLipidNET, I think the earlier podcast with Maria Fedorova will cover that one.
Yes, with whom I have the pleasure to work. So these EpiLipidNET, in fact, this is modified lipids, mainly oxidized and nitrated lipids. So, but in our lab, we are mainly focused on oxidized and nitrated complex lipids, namely phospholipids, sphingolipids, glycolipids, that are the lipids from chloroplasts, triglycerides, and more recently, the challenge of sterolipids. So we also aim with this work to develop, to accomplish new knowledge and also to understand the metabolism of lipids in living organisms, either in health and also, of course, in disease or in other situations, now with a more broad range of applications, but also having in mind the aims and to fulfill the needs tailored by the societal needs. All these have tailored the main line of research that we have now in the lab. So that are lipidomics in health and disease, food and nutrition, also lipidomics applied to marine organisms and algae, and a very amazing field that is microbial lipidomics. That's from time to time, it is a very interesting field, but still very challenging.
So lots of very, very strange lipids from microbes that I think there is far more to be discovered yet.
Yeah. Yes, the challenge of microbial lipids is not only because they have different type of lipids, but also when considering the lipids that we know, like phospholipids, the profile is completely different. For instance, I remember that the first work that I read about E. coli lipidome, in fact, that was an extract on that time also available on Avanti, and they said that the lipidome included, or the lipids included cardiolipin, phosphatidylethanolamine, phosphatidylglycerol, and others. So the others are huge.
Yes.
Well, but in fact, we started with lipid analysis also in this field of health and disease. So it always fascinated us because the lipids are in all living organisms and they have remarkable functions. And also, so we started to develop analytical strategies based on mass spectrometry. First, to look to the oxidized lipids, because just to see what are the typical fragmentation pathways and how they behave, the possible exomers, especially the ones produced by reactive oxygen species, because there are also a very interesting work, and on that time there was already a very interesting work on oxidized phospholipids driven by enzymatic reactions, such as the work that is being done by Valerie. And so we just tried to see how was and how is the diversity and the complexity of these modified lipids by reactive oxygen species that are unspecific and generate a huge amount of different structures. At the same time, we have produced some of these oxidized mixtures. And so also we started to look on the possible biological roles in inflammation, either stimulating immune cells, also in collaboration with some of our colleagues, experts in inflammation. And in fact, oxidized phospholipids are well known for their remarkable role, especially in cell death, in apoptosis, in ferroptosis, and also in inflammation. About inflammation, oxidized phospholipids are remarkable molecules because they usually oxidized lipids are associated with bad effects. And in fact, most of the work that has been done for oxidized phospholipids are related with pro-inflammatory effects, but also now there are already some research work, and also we also found some of these trends in our work, that some lipids or oxidized phospholipids can have anti-inflammatory effect or immunomodulatory effect when the cells are in the presence of pro-inflammatory stimuli, like we are doing in vitro using LPS as a pro-inflammatory. Some of the work that is already published in other groups, like in case of Boschkov, that have done a very interesting work in this subject, that these pro or anti-inflammatory effects of oxidized phospholipids depends on the structural feature and also on the concentrations, on the cell, and on the living conditions. But still, they can be very promising candidates or understanding these oxidized modifications and of concentrations, and also the signaling that they can modulate can open new avenues for strategic new therapeutic strategies, or even for new drugs for modulating the inflammation, especially important in chronic disease. Why chronic disease? Because there are, although we have already available commercial anti-inflammatory drugs, they still are not very effective for most of the chronic disease, and also this chronic administration is also associated with adverse effects.
Yes, things like the cyclooxygenase inhibitors, ibuprofen, you can't be on it for any length of time without getting really bad stomach problems.
Yes, still about the lipids in disease. We are also doing some work trying to identify the plasticity of the lipidome, to identify some biomarkers of disease. So as we are an analytical lab, so we do collaborations with other colleagues from medical schools or even hospitals. So we have looked to different type of disease like cancer, cardiovascular disease, and diabetes, obesity. So, but still, this is a very fascinating world. How the questions that there are still on the table. So what are the specific biomarkers of each disease? So to the validation, the harmonization that is needed for the analytical workflows, also for the sample and data analysis, to have reference values, and also to make data comparable so it can be translated to the clinics.
Yes, it's vital to know what you have in order before we can develop assays, which is what Anne Bent was talking about in the last podcast, or maybe the one before that, I forget, was talking about translating lipidome analysis into the lab.
For sure, it will happen. When, we really don't know, but for sure it will happen.
And a lot of your research is on marine lipidomics, especially on algae. What's special about the lipids of algae, and how do they differ from the lipids of humans?
Yes, this is very interesting. So just after probably more than 10 years ago, we started to look to lipids from marine origin. Also, first because there was the interest in our country, and also in our university, to look to the marine resources, to take advantage of these marine resources. And also because they are also very important nowadays as a source of omega-3 fatty acids, not only because omega-3 fatty acids are beneficial to health, but also due to this problem that we have nowadays with the bad diets and the imbalance between omega-3 and omega-6 fatty acids. So then we started to look to algae. In fact, we have producers of in aquaculture of seaweeds just nearby our university, very close, and that work together with the university. And so we started to identify the lipidome of seaweeds. And meanwhile, so the interest in algae just started to emerge at European and international level, also as an alternative sources of fish for these omega-3 fatty acids, because
the adverts on TV for omega-3 all sell fish oil.
yes,
but fail to mention that the fish are not making omega-3 fatty acids. They're getting them from the diet themselves.
yes, that's true. This is first question that is very important. In fact, fish get their omega-3 especially from their diet, plankton that are mainly composed by macroalgae. And also, they are really a very good alternative to these fish oils, because to get as population is increasing and demand for fish is increasing, for fish oil is increasing, so there is also the problem of overfishing also together with the fishing itself. So algae is also pointed as a very sustainable alternative to fish as a source of omega-3, because they can be easily produced also in aquaculture, not competing with agriculture crops. They can also be produced in, of course, salty water, and so not competing for water and not competing then with agriculture. Of course, algae has always been used in a lot, especially in Asian countries, for food and also traditional medicine. And some studies also pointed out that people from Asia has low incidence in cancer. So also some research has been conducted to understand the health benefits or source of algae as a source of bioactive compounds. And some lipids have also shown some bioactive properties, especially because unique from algae is that they have also a lot of C20 polyunsaturated fatty acids, or C20 omega-3 polyunsaturated fatty acids like EPA 25 and DHA 22,6. Because omega-3 fatty acids with C18 chains, we can see in plants and seeds, like a lot of seeds and nuts. But in the case of C20 omega-3 fatty acids, we can find them also in fish, of course, and in algae. And they are the precursors of the anti-inflammatory eicosanoids, the resolvins, myrisins, and protectins. And in addition, they have these remarkable glycolipids that I only I was aware of their importance when we started to study the lipidome of algae. These glycolipids that are the main building blocks of membranes of chloroplasts. In the case of algae, they are also the main transporters of these omega-3 fatty acids, and also they have intrinsic bioactive properties, especially as anti-inflammatory, again, inflammation, very important, but also as antibacterial. That also, it's not being explored, but for sure it will be very promising. So they are very attractive for application in different industries like nutraceuticals, cosmetics and cosmeceuticals, and also pharma industry. But still, the main challenge in this area is that there are a lot of algae, but the lipidome of them, most of them is still unknown. It's just very few recently people started to identify the lipidome. And also they are very complex and diverse. We have for the most the commercialized ones, we have compared the lipidome, and in the case of macroalgae, we have compared the lipidome of 6 of the most consumed microalgae, and among 420 lipids that we have identified, only around 17 were common to all of them. So it means that the lipidome of algae is algae specific, meaning that we need to identify all of them to know what they have.
Yes. So there are a lot more molecules to be added to lipid maps.
Yes, of course.
Fully determined.
Yes, of course. And of course, it offers a very remarkable opportunity for application and exploitation.
And we added these as a new class to lipid maps in collaboration with you a couple of years ago, the betaine lipids, which are,
yes,
as I understand it, and you will no doubt correct me because I'm probably wrong, phospholipid mimetics, but without the phosphate group.
Yes, in fact, yes. These betaine lipids, they have also they have a polar-red group with a negative charge group and also a positive charge group. And in algae, they exchange with phosphatidylcholine for their role as building block in the membranes. So it's quite interesting because these betaine lipids are almost exclusive from algae, some fungi. So, but it's remarkable. Just only to point it out about the algae, that the European Union is aware of the importance of this algae as an alternative, as a sustainable food and source of nutrients. And there are several initiatives that are also advising the use of algae, especially in diet or also for the production of natural ingredients in alternative to synthetic ones, like the Green Deal, Farm to Fork, and also recently Food 2030 initiatives.
Certainly here in Northern Europe, algae are not really on the menu at all.
Well, yeah, but here in Portugal, there are already some restaurants that are just using algae, especially seaweeds when they are fresh. They don't have that so strong flavor and also smell, so it depends a lot.
Now, having said that, there is a Welsh speciality called lava bread, which is made of algae. But,
yes.
But in my 4 years in Wales, I don't think I've ever seen it. So it's
yes, because it's interesting because even in Europe, in old times, some especially small populations that live near the coast used to eat seaweeds.
yes,
but yes,
when at the times when we were eating locally what was available,
yes,
and not eating whatever was in Tesco's.
yes, yes. In fact.
And of course, you're very active in the EpiLipidNET consortium, which works very closely with us at Lipid Maps. Can you tell us any new developments in EpiLipidNET?
Well, first, it's a pleasure that EpiLipidNET is networking with Lipid Maps since the beginning, even since our application, because EpiLipidNET is a project, is a cost action funded by European Union. So this EpiLipidNET is now, it's growing every day. Now we are more than 450 participants from all over the world. Participants are from 46 countries and 6 continents. Really, we could fulfill our objectives to bring together people with interest in lipids from academia, industry, clinics, and society, and also build a pan-European network.
That's really impressive.
Yes. Also, thank you for the. I want to acknowledge the collaboration of all that people that are also working with EpiLipidNET. And especially also, of course, Lipid Maps. So this is a project, so we will finish in October 24, so quite soon. So we are conducting efforts just to sustain the net and this very interesting collaborative network just after the project. So with the with Maps, we are always working and collaborating very nicely, and also with other scientific societies like International Lipidomics Society or even metabolomic societies and others. So we want to have initiatives that where EpiLipidNET members can join together and continue this networking and these activities with the common goal of enhancing the knowledge on lipids. So one of the initiatives that we have to keep our network alive is in collaboration with Lipid Maps that we have launched the EpiLipidNET Community Forum. I invite all of you to join. So it will be a place where we can continue our network and discussing all the topics of interest with lipids.
Yes, it would be great to see lots of people there and lots of conversation. And if people want to join the Lipid Maps homepage at lipidmaps.org, the community button in the top bar at the top, and then the forum section under that menu is where you'll find it.
Yes, it's very interesting. And of course, we still have other initiatives. There are new projects emerging and also new collaborations, and we believe that we will continue all these initiatives and we will be together. And of course, Lipid Maps, that is also our supporter for sure for the future.
Well, it's been great talking to you, Rosário. It's been a really interesting tour through the work you're doing there in Portugal. And thank you very much.
Yes, thank you so much. Thank you so much for the invitation.
And please join us again for the next Lipid Maps podcast.